Alright, Mr. Walker back with another video on simplifying expressions with exponents. Same four questions. What type of problem are we trying to solve? We're trying to simplify an expression when the exponent is negative. How do we know what type of problem it is? Well, there's an expression where you have an exponent that is negative. So, x squared is positive, but y has a negative 4 up here. And then another way this will happen is if we look at our division rules, we subtract. So I've got 3 minus 4 is going to be equal to negative 1. So after we apply our quotient rule, we're going to have x to the negative 1 here. How do we do this? We're going to use our properties of exponent. There is a property for negative exponents. How do we check our answer? The same as the rest of the videos we've talked about with exponents. We don't have an equation, so there's not anything we can plug in, but we can always go back and double check our work in our arithmetic, which is why we show our work, so we can go back and double check it. So we've answered our 4 questions. Let's get into it. All right, so what happens when you divide powers with the same base and we get a negative exponent? So we've got a 2 here and a 4 here. Based on our rules, we're going to subtract and we get a negative 2. So let's work this out long ways so that when we get down to our property in a second, it'll make more sense. We started out with 3 to the second. That is 1 3, 2 3s. We've got 4 on the bottom. 1, 2, 3, 4. Once we cancel this 3 and this 3, I'm left with 2 3s on the bottom. So my answer is 1 over 3 to the second. If I did the actual subtraction over here off to the side, 3 to the 2 minus 4 is going to be equal to 3 to the negative 2, which looks like that. So that's an explanation of our property. Let's go down and look at our property again. Same 2 versions as every other video. First, we'll start with numbers. 3 to the negative second is equal to 1 over 3 to the second, meaning when I have a negative exponent, I put it in the denominator of a fraction. The algebraic version of this, we're not using numbers anymore, we're using variables. If I have a to the negative n, I have a negative exponent, I simplify that by putting my exponent expression in the numerator, so long as a does not equal 0. If we remember our division rules I said earlier in the previous video, we never divide by 0. And again, I'll say, try to divide by 0 in a calculator. Enter it. Your calculator will give you an error. Okay? So let's look at another example. We've got 5 to the 6th, 5 to the 8th. Our division rules say we subtract. 5 to the 6 minus 8 is negative 2. I have a negative exponent. I simplify that by moving it to the denominator. 5 times 5 is 25. Check. How do we check our work? Go back and look real quick and make sure we didn't make any mistakes with our arithmetic. 6, 8, 6 minus 8 is negative 2. My negative 2 is here. We're good to go. So, let's look at a version where we're not using numbers. Now we got variables. I've got 2 and a 5. Our quotient rule says if we're dividing exponents, we subtract. 2 minus 5 gives me a negative 3. I simplify it by putting negative into the 3 in my denominator. N to the squared minus divided by n to the fifth is 1 over n to the third. Okay? Let's look at one more because this tends to give people problems because we have to do two different things. We're using our quotient rule, which then gives us a negative exponent, and then we have to apply our quotient rule. So, we've got x squared, y cubed, x cubed, y, and we can add a 1 there. So let's set up our problem. X to the 2 minus 3, y to the 3 minus 1. 2 minus 3 is negative 1. 3 minus 1 is 2. So when I simplify this, I'm going to get y squared over x to the 1, or y squared over x. How do we check our work? Go back and look at our arithmetic. If you've shown your work, this isn't difficult to do. I got a 2 and a 3. 2 minus 3. I've got a 3 and a 1. 3 minus 1. 2 minus 3 is negative 1. 3 minus 1 is 2. My y squared is in the top. My x is in the bottom. Check. That's how we simplify expressions when we have negative exponents. Thanks for watching. Bye.